Okay, so here we go. Every one of these problems, I'm going to follow the same three basic steps. All right. Step one is always, in every one of the free body diagram problems, I'm going to give you either the mass or the weight. You got to find the missing one. Okay. Numbers 1 and 2 show you how to do that, or they don't show you how to do that. They make sure you know how to do that. All right. So that's always your first step, is identify mass and force of gravity. Step 2, if there are any given forces, you write those out. If it says Roy pushes with 30 newtons, then put in Roy's force. If it gives you the force of friction, put in the force of friction. All right? Step 3 is the tough part. Step 3, you need to ask yourself, do I know the acceleration? If you do know the acceleration, then find your net force by using this equation. All right? If not, then you're going to know all of the forces, and you can find your net force using this equation. All right? So as I go through these problems, I'm going to model that process. All right? Please, please, please make sure you follow along, and please make sure that your drawings on your paper look the same as the drawings that I made here on the board. Okay? All right, so here we go. Numbers 1 and 2 ask you to find the mass and the weight. So 32 kilograms. If it didn't explicitly say it, how would I know that that's mass, you guys? Because it's kilograms, right? And when I ask you to find weight, what am I really asking you to find? Force of gravity. So if you know the mass, you find the force of gravity. Okay. Oops. All right. So usually that's what happens. In most of the problems, I give you the mass. And that's how you find the weight, how you find the force of gravity. Good? John, you good?
Yeah.
Can you see from back there?
Yeah.
See more? AG, acceleration of gravity. All right, and remember, you guys, this acceleration of gravity is always going to be negative 10, right? Good? All right, number 2, instead of giving you the mass, this time I give you the 730 newtons. So what's the 730 newtons a measure of? That's the force of gravity, right? So to find the mass, you got to divide by the acceleration of gravity. So my force of gravity is 730 newtons. I'm going to divide that by negative 10 meters a second squared. It gives me negative 73 kilograms, but you can't have a negative mass. So how did we resolve that the other day? What do you got, Stephen?
Either make the 10 positive or make the counterpart.
Good. Why would the force of gravity be negative, you guys? Because gravity pulls stuff down. Cool? So on the rest of this sheet, pretty much every problem is going to begin with you either using the mass to find the force of gravity or using the weight to find the mass. Good? And again, just to emphasize, remember, weight is force of gravity. Same thing. Weight is force of gravity. Good? Questions? All right. So here we go then. Okay, so our job then is, for each of these situations, A through I think it's J, for each of the situations you need to make a free body diagram. You're going to identify the object and label all of the forces on it, and then off to the side you're going to write down the acceleration and the net force and the velocity if you know it. Okay? So like somebody in my first hour kept saying, I don't get it, what am I trying to find? Am I just trying to find the net force? That's a piece of it, but that's not all of it. Your goal is to get this drawing with all of the forces labeled. All right? Zane and Willie, you guys need to be following along, please. All right, sorry, I don't know why I singled you guys out, but make sure you're following along. All right, okay, so in 3A, we got a 25 kilogram pumpkin. So draw a pumpkin or draw a box, I don't care. I'm going to draw a pumpkin. There, pumpkin. All right, the 25 kilograms. Is that mass or weight? Mass, right? Because it's kilograms. So step one, identify mass and force of gravity, right? So how do I find the force of gravity, guys? Mass times acceleration of gravity. You're just going to take the mass and multiply it by -10, right? You don't have to write it out. I mean, like you can multiply by -10 just by, you know. So your force of gravity here is going to be 25 times -10. That gives you -250 newtons. Okay? So, this is the one problem where it's actually, remember I said there's two types of problems, problems where you know all the forces and problems where you know the acceleration. This is the one type of problem I could give you where it's sort of both, okay? Because, are there any forces on this thing besides gravity? No, because it's in free fall, right? That's what free fall means. Okay? So the only force is gravity. So I know all my forces. So what should my net force here be, you guys? -250, right? Remember, net force is the total of all the forces. If there's only one force, then your net force is the same as that force. All right? And then what's the acceleration going to be, guys? -10, right? Okay? So this one's kind of a silly one. Okay? But on a test, to get credit for this, you would need everything that I just circled. Okay? Drawing with all the forces, net force, and acceleration. Okay? Any problems with this one? Yes?
How did you get the acceleration was -10 meters?
So, a couple ways. First of all, I know it's got to be -10 because it's in free fall.
Oh,
Okay? Now, if you weren't sure of that, you could calculate it. This would be a little bit silly, but there's no reason why you couldn't do it. Remember, acceleration is net force over mass. So your net force is -250. Your mass is 25 kilograms. Divide it out, and you get -10 meters a second squared. So that's another way of doing it. Make sense?
yeah, well, and on the notes, there was a part that said you have to, like, use the force, like, have the force.
There aren't any missing forces here. So we're going to do problems later on where it'll be like, we won't know the force of friction. And so you'll call the force of friction X and you'll solve for it. Or you won't know Roy's force. You call that X and solve for it. Okay? So we'll get ones like that for sure. All right, is everybody good? All right, as a quick side note though, just because you just brought this up too, I want to make sure you guys understand too, the examples in the notes were almost identical to these examples. Okay? So when you get stuck on these problems, go back and look at your notes and make sure you're taking good notes. All right? Now, I understand that doesn't solve it because you're like, well, great, but I can't ask you questions when I watch the notes because they're these stupid videos. I get it. But it at least is a push in the right direction, right? Okay. All right, are we good or no? Okay. All right. B, a 130 Newton watermelon is being held at rest by Sally. So, start by drawing the object. Oh, one quick thing real fast. On this, I forgot to talk about this. When you're making your drawings, you guys, this is something I have not stressed yet, but it's going to be important on the final, is that when you draw your force arrows, the bigger the force is, the longer your arrow should be. Okay? On this one, it didn't matter because there was only one arrow. Okay? But as I move forward, what you're going to see is the more force is being exerted, the longer I'm going to draw the arrow. Okay? So try to get in the habit of doing that, and I'll try to be better about reminding you about it. All right? Okay, so here we go. In B, we've got a 130 Newton watermelon. So here's our watermelon. Okay, so 130 newtons, is that the mass or the weight, you guys? It's the weight, that's the force of gravity. Right? That's the weight. It's the force of gravity. Weight and force of gravity are the same thing. So my step one is identify mass and force of gravity. Well, I know my force of gravity, I got to find my mass, right? So how do we do it? How do you find the mass? Divide by 10, right? So 130 divided by 10, or -130 divided by -10, you get 13 kilograms, right? Good? Alright, so that's that. Step 1, mass and force of gravity. Step 2, are there any given forces? Not really. It tells me that Sally is doing something to the watermelon, but it doesn't tell us how much force she's exerting. So read it and kind of go, I'm going to need to be thinking about Sally, but I don't know how much force she's got. All right. So remember, there are two types of problems. Problems where we know all the forces and problems where we know the acceleration. We don't know all the forces because we don't know Sally's force. That means we must know the acceleration. What is it, you guys? 0, right? It's being held at rest. Oh, that means my velocity is 0, and it's constant, right? Oh, that means my acceleration is 0, which means I can find my net force. Net force is mass times acceleration. So mass times 0 is going to give me 0, right? Everybody good up to there? All right, so now I can find my missing force. This is what he was just asking about. We don't know Sally's force, so find it. Well, most of you can figure it out without doing the math. What does Sally's force have to be, you guys? It's got to be 130, right? So if you know that, great, put it in. If not, use the equation. Net force is, by definition, all the forces added up. So for us, it's gravity plus Sally. My net force is 0. My force of gravity is negative 130, and Sally's force is x. So add 130, and you will discover that the force of Sally is 130 newtons. And notice I made these arrows about the same length. Does this make sense? We good? Any problems with this? So if this was a test, to get credit, you would have to have all of that. Okay, so look, make sure you've got all that. Are your forces labeled? Do you have your mass? Do you have 2 arrows with arrowheads? Do you have the acceleration and net force written down? Cool. Any questions before we go on to C? Yeah, keep on. The velocity I'm a little bit lax on, to be honest. Yes, unless I specifically gave you a question that said, what's the velocity at this moment, I probably wouldn't make points off for it. All right, are we good? All right. This one, a 0.6 kilogram stack of waffles is sitting at rest on a table. So here's the table, here's the waffles. 0.6 kilograms, mass or weight? Mass. So what's the first thing I should do? Put in the force of gravity, right? So 0.6 times negative 10, my force of gravity is going to be negative 6 newtons. Okay. Somebody's thinking something that will save us some time here. It's the same as the last problem, right? With one important difference. In the last one, why wasn't the watermelon falling? Because Sally was holding it, right? Now, why aren't the waffles falling? Because the table's holding it, right? What do we call that force from the table, you guys? Normal force. Cool. Do we have questions on C? Yeah, if you didn't hear him, Dexter just said, so if it's a person holding it, then it would be the force of the person, force of Sally, force of Roy, force of whatever. If it's sitting on a table, on the floor, on a shelf, on a credenza, is that a thing? I don't know what that is. Is that like a couch or, I don't know, whatever. Anyway, if it's sitting on some sort of an inanimate surface, then you call it normal force. Cool? All right. All right. 80 kilogram filing cabinet sitting on the floor, and then Roy lifts it using a force of 920 newtons. So here we go. Draw yourself a filing cabinet. Mass is 80 kilograms. Start by putting in your force of gravity. 80 times negative 10. Oh, that's negative 800 newtons. So that's step one, mass and force of gravity. Step two, any given forces. Are there any given forces? Roy. I'm going to draw Roy's force. I need to draw it longer than the 800 newtons, right? Because 920 is more. So I'm going to try to draw the arrow a little bigger to indicate that it's more force. Oops, that's an N. Can't tell. Good? All right. So that's steps 1 and 2. Step 3. Do I know the acceleration? No, I don't. I know he's lifting it. I don't know what the acceleration is. Do I know all of my forces? We do, but stop and make sure. Is there a normal force? There isn't. Why not? Because Roy lifted it off of the floor, right? That 920 newtons is going to move it off the floor, right? So there's no normal force. How about friction? It's not sliding on anything, so that's it. These are all of our forces. So now to find my net force, what do? Add them up. Force of Roy plus force of gravity. Does the order that I add the forces in matter? No. So let's see, what am I going to get? I'm going to get 920, oops, plus negative 800 gives you a net force of 120 newtons, right? Roy has 120 more newtons than gravity. So now I can find my acceleration. It's net force over mass. Problems, you guys? All right, there's another problem later on the worksheet that's the exact same thing as this. So when I get to it, I'm just going to say that's the same as D. So when I say that, this is D. All right? Everybody good? All right. I guess just to be clear, to get credit on this thing, that's what you'd have to have. Ideally, you'd show some work. But... All right. E. Roy lifts a 60-kilogram box straight up with an acceleration of 4 meters per second squared. So, 60 kilograms is the mass. Start by putting in your force of gravity. So that's step 1. Mass and force of gravity. Step 2. Are there any given forces? Not really. It mentions the force of Roy, but we don't know what it is, right? That's probably going to end up being my X, I'm guessing, right? Since it alludes to the fact that Roy's pushing it, but doesn't tell us how much force he's using. Okay. Let's see. So that's steps 1 and 2. Step 3. Do we know the acceleration? Yes. So when you know the acceleration, what do? Find your net force, right? Net force is mass times acceleration. So my mass is 60 kilograms. My acceleration is 4 meters a second squared. Multiply this out and you get 240 newtons. Good? All right, so am I done? No. Because look, my drawing doesn't show the net force being 240. Right? The net drawing shows it being like negative 600. So, oh, Roy's got to be pushing this thing, right? So find it. Net force is force of Roy plus force of gravity, right? Aren't those the only two forces? There's no normal force because it's not on a table. There's no friction. I think we're good. All right, so let's see. Our net force, I'm going to plug in my numbers. Net force we decided was 240. That equals the force of Roy, that's what we don't know, plus my force of gravity, which was negative 600. How do you solve it? Add 600 to both sides, and you get x equals 840. Put it on your drawing. Notice my answer came out positive. What is in this problem, what does a positive force mean? Up, right? So trust the math, you guys. The math will tell you the signs. Just tell you the direction. What else did I do when I just drew that arrow? Made it longer than gravity, because it's more force. Good. Questions on E? Okay. Everybody good? Alrighty. Am I going too fast? Are we good? Isla, how you doing back there? You good? Jacob, how about you? You good? Shayla, you good? Haley? Alright, F. This is the same as D. So I'll run through it real quick. Here's what your answer should look like. 60 kilograms. Gravity. That's a 6. Force of Roy. Net force turns out to be 120. Acceleration turns out to be 2. Same as D. Good? All right. All right, question G. We've done tons of problems like these. So for a minute, let's forget about... Do I want to do this? Here it is. So a hockey puck is sliding on frictionless ice. What do you need to do to keep it moving? Nothing, right? Okay? Technically speaking, there are two forces. Up until now, we've ignored those forces. Now we got to put them in. What are the two forces? Frictionless hockey puck. If you've got a hockey puck sliding on ice, isn't gravity pulling it down? Up until now, we've ignored it, though. Why? Yeah, I mean, the problem is about something moving horizontally, right? Okay, so like when we first started this chapter, we ignored gravity, and I said the reason we can ignore gravity is because the ice is holding it up, and those two forces cancel out, right? Okay, so we're doing the same problem we've been doing. The only thing we're doing now is we're going back and adding in those forces that we had ignored before. All right, I apparently shouldn't have brought it up because a lot of you are looking puzzled. All right, so here, check it out. Look, here's the deal. We've got a box of Count Chocula. It's got a mass of 0.8 kilograms. So right away I can put in my gravity. 0.8 times negative 10 is going to give me negative 8 newtons. It's sliding at a constant velocity of 5 meters a second. So I'm going to draw in a little velocity vector there to indicate the direction of motion. All right. Now, because the velocity is constant, automatically I know that my acceleration and net force are 0, right? Cool? All right, so what other force do I need to put on my drawing? I already got gravity. Why isn't the box of cereal falling? Force of the table is holding it up, but I don't call it force of the table, I call it normal force. And it's got to be 8 newtons to cancel out the gravity of 8 newtons, right? And that's it. There aren't any horizontal forces, right? Because it's a frictionless surface. Does that make sense, you guys? Okay. I had to talk about this one for like 5 minutes last time. Is everybody good with it? You guys understand there's nothing pushing it forwards, nothing pushing it backwards, it's just sliding along, right? Okay, great. Okay, question H. A 12 kilogram box is pushed across the floor at a constant velocity of 4 meters a second. But this time there's friction, 20 newtons of friction, so let's draw it. So here we go, mass is 12 kilograms. Right away I can put in my gravity. So that's step one, mass and force of gravity. So I think we can probably safely say this at this point. Look, you guys, in this class, anytime you've got something moving horizontally, automatically your normal force and gravity are going to cancel each other out, right? Because if it's moving horizontally, it's not going up or down at all. So automatically I can put in this normal force and call it 120 newtons, right? And notice those two arrows are about the same size. Everybody good? Okay, cool. All right, so that's my step one, mass and force of gravity, and normal force. Next step, any given forces? Are there any given forces here? I know the velocity, that's not a force, but I do need to identify the velocity because that's going to tell me the direction of friction, right? So I chose to make the velocity this way, which means friction is going to be that way. See how small I made the arrow? Why did I make it small? Because it's much smaller than 120. Cool? Anna, you good? I know, I just noticed that. I had to resist the temptation to go, it's snowing, everybody. But now we're talking about it. So, it's snowing, everybody. It's not snowing, everybody. That would be weird because you guys would all be falling. Gotcha. Okay. All right. Are we good with what I've done so far? All right. Am I done?
No.
No, why not? Okay, yeah. So, do I know my acceleration or do I know all of the forces? We do know the acceleration. A0, well, I can find them, but I don't know them all yet. Since the velocity is constant, I know that, right? So, Lucy, tell me what you think of it.
I was missing force, like that we said.
Uh-huh.
So the velocity first, can we assume that the force of the push is 20 newtons?
Yes. Yes. It's not an assumption. It has to be. Right? Because we know the net force is 0 because the velocity was constant. Okay? And what Lucy's focusing on is this. The box is being pushed by something or someone. Let's assume that it's Roy, because it's always Roy. What does the force of Roy have to be, you guys? 20 newtons, right? Because my net force has got to be 0. Because of the, well, okay, right. So earlier we were only doing 2 because we hadn't learned about gravity yet. Okay? Now that we've learned about gravity, you always have to draw all the forces. Yeah. Actually, let me be more explicit about that. If I want you to draw all the forces, the instructions will say make a free body diagram, make an FBD. So if it says make an FBD, then you have to draw your forces. If it doesn't explicitly ask for one and it doesn't matter, then I guess I don't care. Does that help? Did that make sense, everybody? It's a good question. Okay. And so the instructions on the sheet were to make a free body diagram. So, all right, everybody good? Okay, we are almost done. Question I. 36 kilogram box. Put in your gravity. All right, so it's being pushed across the horizontal floor, so automatically I can put in my normal force. So that's step 1, put in your mass and your force of gravity, and I tacked on my normal force. Step 2, any given forces. Oh, it's being pushed. Oh, shoot. What did I do wrong?
Your arrow.
That arrow is way too long, right? If this is 360, then 96 is going to have to be a little bit shorter, right? So here's the force of the push. So you can call it FP for push, or Roy for Roy, or U for U, whatever. On the test, I'll make sure I give names. Okay? And then friction is 54 newtons. Good? All right. So that's steps 1 and 2, right? I put in mass and force of gravity, and then I labeled all the given forces. Step 3, do I know the acceleration or do I know all the forces? We know all the forces, right? So find your net force. So net force is all the forces added up. I'm only going to worry about Roy and friction. Why? The other two guys cancel, right? So my net force is going to be 96 plus negative 54. Gives us 42 newtons for a net force. All right, and then our acceleration is net force over mass. Cool, you guys? Any problems? What? 1.17. All right, we're almost done. We just have 2 more to do. J. This one was on the last target check that we went over, basically, except now we're putting in gravity and normal force. So here you go. 36 kilogram box. Let's start making this force longer. There's going to be a normal force because it's sliding horizontally. It's being pushed with 120 newtons. So that's steps 1 and 2, right? I put in my force, gravity, and my mass. I put in my given forces. Step 3, do I know the acceleration or do I know all of the forces? We know the acceleration is 1.4, right? Okay, so do I know all the forces? Could there be any other forces? Yeah, there might be friction. We don't know yet. But when we find our net force, we'll be able to figure this out, right? So check it out. Net force is mass times acceleration. So 36 kilograms, 1.4 meters a second squared. You get a net force of 50.4 newtons. So now, is there friction? There has to be, right? Because Roy's pushing with 120 newtons, but for some reason my net force is only 50. So my missing force is friction. So here we go. Let's figure out how much friction there is. Definition of net force is all the forces added up. For us, it's Roy and friction. Again, I'm not going to worry about gravity or normal force because they cancel. Okay, so we're almost done. Plug in your numbers. Let's see, net force is 50.4. Force of Roy, oops. Force of Roy is 120. Force of friction is X. Solve it by subtracting 120, and you find out that your force of friction is negative 69.6 newtons. Just trying to make that arrow shorter. Cool? Any questions? I know, I'm sorry. We're going to do one more problem. Last one's quick. All right, are we good? All right. Okay, finally, last problem. Thank you for being patient. I know this has been a lot of me talking. All right, so this time we got this 50 kilogram crate of gummy bears sitting on a frictionless floor. So here's the crate. Listen up, you guys. Thank you. I know you guys are tired of listening to me talk. All right, so it says Roy pushes the box to the north and Sally pushes west. All right, so technically speaking, gravity's going to pull the crate down and the normal force is going to push up, but those are going to cancel, right? So what we're going to do is we're going to make a top view free body diagram. So we're going to have north, south, east, and west. And then down would be like into the board, and up would be out of the board. Does that make sense, you guys? Okay. So in this one, Roy's pushing north with 60 newtons. Sally's pushing west with 80 newtons. And then there's gravity and normal force, but those cancel, so we don't care about it. So A says make a free body diagram. Or, well, it says make a free body diagram, so we did that. Then find the net force. So, first of all, is everybody okay with the drawing? All right. What's up? Because west is a negative direction. Because it's to the left. Everybody good? All right, so to find the net force, listen to this, please, you guys. This is important. Will, yes? You've never seen this before, so. To find this net force, you can't just do 60 plus negative 8. Because they're not linear. Like, they're not on the same line. So how do you think we're going to deal with it? Say it again. Oh, I gotcha. No, we don't need to worry about the 50 or gravity because it cancels out with the normal force. So do you guys remember when we did projectiles, we had problems where like a car was driving at 20 meters a second horizontally, but then because of gravity it was moving vertically at whatever, negative, I don't know, 15 meters a second, say. How did we find the overall velocity? Pythagorean theorem. We're going to do the exact same thing here. Okay? Because look, there's a force this way, to the left, there's a force up, so it's going to move up and to the left, right? It's going to go northwest, right? So here's your drawing. When you draw the arrows, you put them head to tail. So, here's my force of Sally. Here's my force of Roy. Here's my net force. Okay, notice how I drew them. It looks a little bit different, right? I took Roy's vector and moved it so that the tail of Roy's vector was at the head of Sally's vector. Okay, if you'd wanted to, you could have drawn it Roy and Sally and hypotenuse. Either way, it's the same hypotenuse. Cool. So do the Pythagorean theorem, your net force ends up being 100 newtons. And once you know your net force, you can find the acceleration very easily. 100 newtons, 50 kilograms, so you get 2 meters a second squared.